So now let's take a look at problem number 3, solving exponential and logarithmic equations. In this third unit, we're going to be solving a lot of different equations and inequalities, and so it becomes important to deal with some of these kind of more abstract or obscure equations, like things with exponential and logarithms, and to try to talk a little bit about how exactly we should be thinking through them. So let's go ahead and start here with number 3, part A. So on this question, we're going to be asked to solve the equation of 3x e to the x minus 2 e to the x equals 0. Now, one thing that we're often going to be looking for when we're solving an equation with multiple terms that contain x is sometimes we're going to be looking for what can we factor from each of these terms. And so as you see here, this is actually a great way to start. I could see that I could factor out something like an e to the x. That would leave me with a 3x minus a 2. And now that I have two items multiplied together to make 0, I know that either one of these items could be equal to 0. So I can just quickly set this up. I need either the first item to be equal to 0 or the second item. Now, as we already talked about when looking at problems in example 2 here, is that e to the x cannot ever be equal to 0. That's not possible. So the only solution I'm going to get here is from solving this little linear equation. And that's going to leave me with that x could actually be 2/3. So this is going to be a possible value that I could get here. If x is 2/3, then I'll ultimately have a solution here. So in general, this type of question isn't maybe too difficult. It's just really important to recall that e to the x can never equal 0 for any value of x. Well, what if I was to take a look at something, say, like part C, where I have an x times a natural log of x equals x? Now, when I have something in a setup like this, there's a really tempting first move that people attempt to make, and that often causes a lot of problems. Oftentimes what students will do is they'll just say, "Ooh, wait, there's something in common on both sides here, so I'm just going to divide both sides by x." And there's a big problem with this. We can't actually do this unless we can be certain of what value x might actually take on. Because I should notice here that if x is going to be the value of 0, then I'm going to be dividing by 0 here, which is never okay. So I can't just go ahead and divide by a variable unless I can be sure that that variable is not 0. So instead, our move is going to be very similar to what we did up in part A. We're going to move everything that we have to one side of our equation. And that item that was in common, we're going to go ahead and factor out. And now again that we can see, we should see that we have two different possible solutions here that could make this work. We have x could be equal to a 0, or we have the natural log of x minus 1, I should say, could also be equal to 0. Now, if I work with this equation over here a little more, I'll see that this would require that I have the natural log of x equal to 1, and I know that this will happen here if x is just equal to the value of e. So it appears that I have two different possible solutions here. That is, if I go back to the original equation and I plug in e, both sides should match. Let's take a look. E times the natural log of e should be e. That works out perfectly because the natural log of e is just 1. So this is definitely going to be a solution that we have here. But take a look at 0, because something interesting actually does happen here. If I plug 0 in for all of the x's, notice I first have to compute 0 times natural log of 0. Well, what's the natural log of 0? Again, if I know my natural log graph, this can be a really easy thing to determine. I should recall that my y-axis here played the role of a vertical asymptote, meaning that I cannot plug in 0 to my natural log function and get a result. There is no result there. And what this means is that x equals 0 is actually not okay. This is like a fake solution. And I do have to check for things like this. This is why when I deal with more complicated functions like natural logs that have domain restrictions, I want to make sure that I'm only generating solutions that it can actually work in the original equation. So here, x equals e is the only value that we would actually be able to use here. Now I'm going to leave part B as a question for you to try on your own, but of course don't forget that the solutions are posted up online.